We present CHIMLE, a general-purpose conditional image synthesis method that generates diverse and high-quality output images. Generated models for images come in two types. Unconditional generated models learn the marginal distribution and generate images with arbitrary objects. Conditional generated models, on the other hand, learn the conditional distribution and allow control over what images to generate through a conditioning input. We focus on the more challenging conditional setting, where consistency between the model output and input is important. Inside conditional generated models, class conditional models have the strongest level of supervision, where they use thousands of observed images in the same class for training. Next is text conditional models, which also use hundreds of images that share the same caption for training. Image conditional models, however, typically have only one observed image for each input to train on. Like in super resolution, only one high-resolution image is provided for each low-resolution input image. This makes it the most challenging setting, which will be our focus. Many existing methods are unimodal methods, which only produce a point prediction. Multimodal methods, on the other hand, aim to generate all possible samples from the full conditional distribution, like generating all possible colors of the grayscale banana. In the real world, however, only one way of coloring is observed, and this makes it quite challenging to learn multimodal methods, and that's the setting we tackle. The predominant approach to learning a generated model is using GAN. However, GAN suffer from the well-documented problem of mode collapse, as shown on the right, where the GAN drops the modes at the top. To address this issue, a technique called IMLE uses an alternative objective, which ensures each observed data point has some similar generated samples, and thereby overcoming mode collapse as shown on the right. Note that this is the reverse of GAN, where each generated sample is only made similar to some observed data points, which is the other way around. CHIMLE extends IMLE to the conditional setting. At a high level, CHIMLE generates a pool of M samples from the conditioning input and a latent code. It then selects the sample closest to the observed image and trains the generator with it. To select a good sample that is close to the observed image, CHIMLE requires a large pool size M. However, sampling is expensive, so it forces an unideal trade-off between pool size and sample quality. To get around this, we observe that the gradient only depends on the closest sample for each observed image. Taking advantage of this, we propose a hierarchical sampling algorithm called Conditional Hierarchical IMLE, or CHIMLE, to efficiently search for a good sample as if it was selected from a large pool of samples. We consider a model that operates on increasing resolutions, which we call TIM, and we divide the dimensions of the latent code into mutually orthogonal components, where each component serves as input to a particular resolution in the network. At each resolution, we also add an intermediate output head, and this enables us to evaluate partially constructed latent codes, where we select the value that produces the sample closest to observed image, downsampled to the same resolution. To construct the full latent code, we start with a component at the lowest resolution and fix the selected value before moving on to a higher resolution. In this way, we can focus our search on the code components for the higher resolutions and find a good sample more efficiently. Compared to CHIMLE, CHIMLE achieves 2.5 times better efficiency in generating samples during training, and 1.7 times better generated image quality during testing. Visually, in this example of colorization, CHIMLE produces more diverse and vibrant colors compared to CHIMLE. In this example of super resolution, CHIMLE attains much better image quality than CHIMLE. We also compare our method to the leading GAN-based and diffusion-based baselines, as well as task-specific methods on a wide range of tasks, including colorization, 16 times image super resolution, image decompression, and night to day. To summarize, in this paper, we identified the sampling cost as a bottleneck for generating high-quality images with CHIMLE, and we introduced a hierarchical sampling algorithm that overcomes this issue. We also developed a general-purpose framework for multimodal conditional image synthesis, which is applicable to a wide range of tasks. For more details, please see our paper and visit our project page. Thank you.